Hello and welcome to this webinar which will be covering flexible, printed and organic electronics. My name is Raghu Das and I'm the CEO of IDTechEx, and I'm one of the analysts who looks in particular at this topic, and over the next half hour or so my aim is to give you an update as to what is the latest progress of the industry and also some of the outlook and trends that we see going forward. A brief introduction for those of you who are fairly new to IDTechEx. We are very much a global market research firm, and our aim is to really help our clients understand complex emerging technologies and their supply chains and the progress of the technologies and players within those different sectors. The sectors we look at are shown on this slide here, and as part of what we do, we add value by providing a range of research reports, consulting projects that we do, and we also do global events covering these different topics as well. And so if you're looking for detailed information about market sizing, forecasting, technology analysis, trends, unmet needs, then we're the people to go to because we can help provide that on the topics covered here. We also provide subscription services, and this is a way that we are in regular contact with our clients, whereby they get access to not just a range of research reports that we provide, but also through our web portal, they can also access a diverse range of company profiles, technology analyses, and critically, they can also access our analysts too. So that can be anything from briefings to ad hoc calls with our analysts to get their opinions on breaking news announcements, or where we can provide, for example, company introductions. So if you'd like to learn more about that service, including demonstrations, please don't hesitate to contact us. We also have a major event coming up on this topic. The event is called Printed Electronics Europe. It's being held in Berlin on the 10th and 11th of April next year. It's Europe's largest event on the topic. We have over 2,500 attendees, over 200 exhibitors are expected, and we're having some 250 plus presentations. And it really covers the entire universe of printed electronics, from those providing materials through to equipment supply, and critically you'll be hearing from many end users from different verticals talking about the projects they're working on with the technology and much more besides that. So it's really the networking place to go to in Europe to learn what's going on, critically bringing together end users with different suppliers so you can really understand what are the needs from different categories. So the information I'll be covering is based on this new report that we have just recently launched, which covers the entire sector of printed, organic and flexible electronics. So if you're looking for detailed 10-year forecasts by different component types, detailed profiles, case studies of what's been successful, what hasn't, analysis of the whole value chain by many different parameters, then this is the report to look at. Take a look at the full contents list at idtechx.com/PE for more details. Now let's get stuck into the content of this session. I'm going to start off by looking at the total market size in 2018. And as you can see, it's a market worth just over $31 billion. And of that, displays are the main aspect. Here we have many different display technologies we look at. One of the key display types is OLED displays, which of that $26 billion is $25.5 billion in 2018. With the other display types we'll be looking at, including reflective displays, for example, being around $500 million. The second largest segment by value is printed and flexible sensors, a $3.6 billion market in 2018. Here we have a range of different sensor types at different points of maturity. We have some markets which are large and in some cases growing slowly as they're maturing, such as glucose test strips, but others which are growing very quickly, albeit from very small bases, such as organic photodetectors and also printed gas sensors. The market size for conductive ink alone, excluding its use in other applications, shown on this slide here, is $1.9 billion. And here we include just the value of the ink, because to include the value of the end device would skew the data too much, but it's being used in a variety of applications, including printing, for example, the electrodes of touchscreen panels, through to printing the bus bars onto conventional PV silicon cells. But there are also many new markets which are being created. I'll be going through some of those examples later in this presentation. And we also look at the full range of other enabling components coming through, from those who are working on flexible logic, printed batteries, OPV and OLED lighting, which are still fairly small in terms of market size, but beginning to grow rapidly now in some cases, getting more interest and going into more and more applications. So I'll be going through each of these components in a bit more depth. But before we do that, I want to take this market size in 2018, which is just over $31 billion, and strip out from it everything that is not predominantly made by printing. So here we're really removing most of the display segment and also the OLED lighting segment. And what we end up with is what's shown on this chart here. So in 2019, the value of the electronic and electrical components predominantly made by printing is just under $6 billion, and that is growing to around $8.5 billion in 2029. The main highlights here include those who are working on printed sensors and, of course, the printed conductive ink sector, where a lot of that conductive ink is mainly deposited by printing. So let's start off by looking at the biggest sector first, and that is the market for OLED displays. This chart here shows the progression of OLED displays away from those being based on glass panels to those being based initially on rigid flexible panels, i.e. it's a plastic substrate, but it's not flexible in end use. It may be curved or it may be on plastic because it's slightly thinner. But also eventually the transition to the third wave, which is fully foldable displays. And by 2020, the number of OLED displays on rigid plastic substrates will overtake the number of glass-based displays. And as you can see, we also start to see, as early as 2018, an increase in the number of sales of fully foldable devices. So let's have a look at the fully foldable display market in a bit more detail. A lot has happened in towards the end of 2018. In September, we had Samsung say it's time to deliver on foldable displays. And so since then, we've had a number of company announcements. Nubia, for example, a Chinese-based company, announced a wearable smartphone device would ship by the end of 2018, shown on the top right there. Then in November, we had, or was it late October, we had Royal Corporation demonstrate their foldable smartphone, which they claim will come to market in December 2018. And you can see the picture in the middle there, where the whole display wraps around the edge. And so when you fold it up, it creates effectively 3 displays, on the front, one on the back, one on the side, but you can unfold it into a tablet-like style. And a week after the announcement from Royal Corporation, Samsung also demonstrated their foldable phone as well, which is shown in the bottom right here. So foldable displays are now coming to market within the next month or two. It's no longer just demonstrators of displays, but a strong trend. And that trend is being driven by the need of many of these consumer electronics companies to differentiate their devices, to create something new, and really provide a platform to increase sales, significantly taking market share from their competition, because at the moment they're doing fairly small incremental changes to smartphone devices. But that is set to change drastically with the onset of flexible OLED displays shown here. But flexibility isn't the only key innovation we have seen. After many years of development, we now see that printed OLEDs are finally commercial. The first printed OLEDs were brought onto the market many years ago by Philips in the form of passive matrix OLED display, and since then we've had well over a decade of many different demonstrators of printed OLEDs being shown. But in December last year, JOLED from Japan came to market with their printed OLED display, which are now beginning to ramp up. A few months ago, they raised around $400 million or so, and with that money, they're creating a larger gen facility in order to make these displays. And I think their real aim, in addition to initially selling the displays, is to get the process correct, get to very high yield, and then be able to sell that know-how along with partners such as Panasonic and Screen to others to enable them to print OLED displays. The benefit of using printed versus conventional types, such as fine metal mask, is that printing would be better to get to larger area display sizes. It cannot be as high resolution, so we don't expect it to be used for small cell phone size displays, but for large area sizes we can overcome the limitations of, say, fine metal mask, meaning that there's no limitation realistically as to what the size of the display could be, unlike with conventional vacuum FMM processes. So here the limitation is really one of yield and going through that learning curve to ensure that we get to cost-effective solutions, but the materials are now very much available in terms of performance versus non-printed materials. Lifetime of the material still has a little bit of way to go, but it's good enough now for some initial applications. So we're watching this area carefully, but it's an exciting development, we think, within the area of printed electronics. But OLED displays are not just the only type of technology that we look at in this report. There's also significant work going on with, for example, printing of quantum dot displays. Now, quantum dot displays are already commercial today. They're being combined with LCDs to improve the quality of LCDs, and Samsung are heavily behind this for TVs, whereas, for example, LG are heavily behind OLEDs for TVs. So quantum dots are around today, but so far they're not commercially used to make emissive displays, where the quantum dot materials themselves are used to emit the light, as opposed to just re-radiate it, as you see with LCD displays using quantum dots on the market. So emissive or electroluminescent quantum dot displays can combine some of the advantages of OLED displays, but also the advantages of quantum dots, which include that they're not as sensitive to water and oxygen versus OLED materials. And here we've seen Samsung announce they're developing a pilot line to develop hybrid quantum dot and OLED displays with the structure shown on the bottom left here. And they've hinted in different announcements and through different news reports that the quantum dot materials will be made by a printing process. So it's not just printed OLEDs we're seeing come to market, but also printed electroluminescent quantum dot displays as well. It's certainly a very exciting area in the display world, and one that we at IDTechEx watch closely. Moving beyond OLED displays, we then have electrophoretic displays. This is a $500 million market in 2017. It still mostly consists of black and white devices. The color filter versions did not resonate well with consumers because the colors were not very good color. But what is good color is spot color, and so these are used in specific applications, and about 30% of the sales of electrophoretic displays in 2017 are for electronic shelf labels, and many of those, not all, but many, incorporate spot color devices. Full color has been demonstrated, but it's still problematic in terms of manufacturing, and this is being worked on, so it's still within R&D, and so prices of this are as yet unknown. But it's something that companies are trying to bring to market because, of course, if we can have the benefits of reflective displays, which are low power and also inherently flexible, but also have them at full color and capable of video refresh rates, then they would be a contender for a larger market share and opportunity going forward. But we also have very simple displays, and one which is now coming back into focus is electrochromic displays. These have been around for a long time, but they've not been commercially successful for various reasons. But now several companies, including Invisible, are really focused on making a success of these. Their benefits include the fact that they're relatively simple to manufacture. They're low power, lightweight, flexible, and some of the challenges they've had before, such as limited range of colors, poor contrast, is now changing, with new work on materials mean that a range of colors are now available or coming to market soon. And the benefit of these is that they can be cheap enough to start to be used on disposable devices, such as indicator labels and other applications like that, where premium end displays will not go. Moving on to the topic of sensors, I mentioned earlier how this is a market in 2018 for over $3 billion, but it really comprises of these 9 different types of sensor technologies that we assess within this report that we cover. You can see that some of those are already in mass production. That includes biosensors, that's mainly printed glucose test strips. We then have piezoresistive or printed force sensors and printed capacitive sensors, all of which are reasonably sized markets. But the largest market by far is the biosensor or the printed glucose test strip market. In 2018, that market size is over $3.3 billion, but actually it's in decline. Over the next 10 years, we see it declining to $2.3 billion through to 2029. And the reason for that is that there's a strong move away from these single-use test strips to continuous glucose monitoring system. And as you can see on the bottom right there, that's a general trend we see, moving away from single test points, which may be difficult to do, they may be uncomfortable, through to continuous monitoring, thanks to new form factors coming through, thanks in many ways to flexible and printed electronics. So other examples outside of glucose test strips include, for example, the temperature body measurement, and there are a number of companies on the market which have skin patches which do that. And there are also flexible skin patches which can also monitor heart rate as well. So this trend towards continuous monitoring trades off accuracy per test, because quite often, in some of these cases, monitoring on the body isn't as good as internal body measurements or taking a measurement from blood, but the benefit is that you can continuously monitor it, and therefore you have more data and you can see how changes in your lifestyle or what you're doing has an immediate impact on the parameter you're trying to measure. The second largest market in 2018 is for printed piezoresistive force sensors. That's $60 million market this year. And of the expanding production of different types of sensors, including organic photodetectors, gas sensors, and humidity sensors, we see that gas sensors in particular will become a large market. They'll become the second largest market for printed sensors by 2025, followed by organic photodetectors. Then we look at the market for conductive inks. I mentioned this is a $1.9 billion market in 2018, and the majority of that, as you can see, shown here in purple, is the use of conductive ink for silicon solar cell panels, where the silver ink is used to print the bus bars and fingers. Now, there's a lot of change going on in this industry, as IDTechEx has covered before in our various reports and our research. The change here is that we're seeing an increasing number of Chinese suppliers of silver paste, and therefore many of the traditional suppliers in the US and Europe and elsewhere in Asia are having to develop new markets because they look to lose some market share going forward in that sector. So there's been a lot of activity on many new types of formulations which are targeted towards different applications, and here we'll look at a few of those going forward. The first is on 3D printed electronics, where a number of companies are now enabling this world of structural electronics, where we can have electronics which can either be printed flat and then, for example, molded, i.e. in model electronics, creating 3D objects, or they can be printed flat and fitted to 3D objects, or even directly printed onto 3D surfaces such as antennas. Examples of commercial products today include, for example, what's shown in the middle center at the bottom here, this device from Tactitech, which is an in-model electronics device which Synto are using as part of a wearable system. It's fully molded and therefore it can be washed with a garment, but giving a secure and reliable connection to the transceiver and the electronics, which is removed and adjusted and put on different parts of the garment as needed. On the bottom right, we have from ADS a product which is also now coming to market. This is again an in-model electronics device, and this is being targeted to headlights on cars. As cars increasingly move to using LED lighting, a challenge they have, which they didn't have before, is that not as much heat is being generated, and therefore the headlamps can fog up, and therefore they may need to be demisted, and that's the idea of those systems there, whereby printing them means that we can print them flat, thermoform them, and it's much easier than trying to put other types of heating elements onto this 3D surface. Another area of growth we see for conductive ink is within stretchable devices, particularly, as you can see here, in e-textiles. And here we're seeing huge improvement in materials, as shown on the top right, over time. First generations of these stretchable materials found that with a lot of strain, as you relax the devices, there'd be a change in conductivity, but with later and later versions, the change in conductivity with strain is far less, and it goes back to nearly its starting point. So these are already being used in a variety of different applications of the textiles. For example, earlier in 2018 at the Winter Olympics in South Korea, a number of suppliers worked, including DuPont, who supplied the material, to put these in heated jackets, which were better than conventional heated jackets with copper wiring because they're lighter weight just by having printed conductors, but they also could stretch and could be conformal to the user. And there's many examples of sports clothing which is available, which use these stretchable conductive inks for things such as heart rate monitoring. So the prices of these materials are falling, and they still need to improve somewhat in terms of the number of wash cycles and so on. But we're seeing continual improvement in the material formulations, and it's not just for the conductive inks, but also everything from the dielectrics, which need to be stretchable to match it, to the encapsulants and substrates as well. We've also seen an exciting year in terms of what's happening with flexible logic or flexible ICs. Two companies really are commercially leading this area, and they are Thin Film Electronics and Pragmatic, and both of those have set up manufacturing this year. Thin Film Electronics are now have the ability to make around 7 billion flexible ICs this year or shortly next year. And Pragmatic also announced that they've initially set up their first Flex IC manufacturing center in the UK, where they can now start to ramp up production of their flexible IC devices. Both these organizations are targeting NFC applications, that is, replacing the silicon chip for low-cost, very thin devices. Some of the benefits they cite are that because the physical size of the flexible ICs is larger than the silicon chip, the benefit is that it can be used as the strap to attach the two ends of the antenna coil, and therefore you can save some money versus attaching a very small silicon chip and creating a bridge to connect the two sides of the coil. But in other applications, they've also found that those who use silicon ICs to tag, for example, bottles, find that those silicon ICs can easily be broken as the bottles chink against each other, whereas a thin flexible IC is much more robust and resilient. And indeed, some companies, such as Carter Mundi, shown here, have said they want to move away from the small bump you can feel the silicon chip, and they're looking for very thin, flexible versions. So there's good reasons beyond just cost that companies are looking at these technologies, although in many cases it will come down to cost, and these companies believe that they can be cheaper to some degree in high volume. The challenge for them now is to get to high volume and bring the price down as quickly as possible, but even before that, finding markets where people are willing to pay a slight premium price for some of the benefits, including the thinness and flexibility of these ICs versus others. One area of plenty of opportunity going forward is the area of hybrid electronics. We're seeing a lot of activity in this space, and that's because not all the different types of components are commercially ready in terms of the whole toolkit of sensors, logic, memory, displays, and so on coming through. So quite often we see silicon ICs, for example, being combined with printed sensors, and here are a few examples of that. We have a strain sensor from Xerox PARC, which uses a silicon IC for the communication and some of the processing, but it's got a printed antenna and printed sensing elements as well. There's a strong need for these sorts of hybrid electronics going forward, where people will mix and match the different capabilities to create the desired different component or product. The challenge at the moment is really about assembling these at a high-speed, automated way, because you're dealing with different substrates, different numbers of rigid components, and even the printed and flexible components may have different thicknesses depending on what you are trying to integrate. There's no good software, to our knowledge, really designed for printed electronics or even 3D printed electronics. That takes into account, for example, when you do in-mold electronics, some parts stretch, and so it compensates for that in the design of the circuit. And so we think that's also an opportunity going forward, and also one for equipment manufacturer to be able to create high numbers of these different devices in an automated way with the ability to change from one device design to another. So this is now beginning to be worked on by some companies, but it's still, I think, a challenge, particularly when it comes to things like being able to handle different size components with different flexibility, and also getting good, reliable conductivity in terms of the connections between them as they're placed together. So one perhaps for some of the callers on this line to think about going forward. And looking at the printing technologies being deployed, screen printing dominates in terms of the type of printing technique being used for commercial devices. So of the market, which I said is predominantly made by printing, which I gave earlier in this webinar, those applications are mainly using screen printing, whether it's glucose test strip, or it's PV bus bars, touchscreen electrodes, and so on. But there's strong growth in other types of printing technologies for commercial applications. And here are a few further examples beyond things such as displays that I've already covered, where we see inkjet printing and also gravure printing being used. Increasingly, for example, we see inkjet printing being used for EMI shielding, and particularly as we see the rise of 5G, the higher frequencies involved mean that there's a stronger need for shielding. And as a result, there's the benefit of inkjet printing them is that you can easily customize from one device design to another. We're seeing technical developments as well. So, for example, XTPL, one company have shown that they can get to very fine printing, down to hundreds of nanometers with inkjet printing, and then a post-process treatment. And so they're using this to repair, for example, dead pixels in displays, so you don't have to throw away the whole panel, but you can repair these and overcome that problem. In other cases, we're seeing inkjet printing being used to replace some processes. For example, Notion systems have now shipped inkjet printing systems to replace the etch resist in a range of different applications in PCB design, particularly for the automotive sector. The benefit of using inkjet printing is that you use less material. You can quickly change from one design to another, and you also reduce the number of process steps needed. On the right, you can see the uptake of gravure printing. So here we see it being used in research and development, but in terms of commercial application, one of the commercial applications we see of gravure printing is that for making transparent conductive films. Here a sub-6 micron line width can be printed consistently and very uniformly with gravure printing, and this is now being commercially used to manufacture transparent conductive film, which is being used to replace ITO in a range of applications for touch screens. But to finish off, I'd like to look at a slide that I drew over 8 years ago. This shows the value chain for the print electronics industry, and the percentage is there, which is still pretty accurate, I think, of where we are today. Show the number of organizations involved in each part of the value chain. About 27% of the companies that we've looked at are involved in material supply, 10% in equipment supply, and then 60% combine all of these to make a whole range of different components. But one of the challenges then, which is still somewhat the case now, is that at the time, there are still very few integration companies or creative designers involved. So it's one thing making a flexible transistor or a flexible display, but a flexible transistor or a flexible battery isn't necessarily a product. And it wasn't enough in some cases to hope that companies would come to you with ideas for those products. What we've seen over the last 5 years are a range of companies who have shifted through this value chain to provide complete solutions. And here are a few examples, and there's many more that can be listed, but these are examples of companies who had started off with a component and they've realized that they've got to become more of a product or solutions company in order to really highlight the capabilities of the technology to those people that use it. So this is an ongoing trend that we see within this sector. So that's the update to the flexible printed organic electronics. It's been an exciting 2018 with lots happening across all fields, as you can see. And I think overall many different suppliers have really targeted now a range of applications they're working on. Some of those are very niche, but they're proving very successful, and others are very grand and bold, such as printing OLED displays, but they're now also, as you can see, in the marketplace. And if you're looking for the full assessment of this whole area, then this is the report to take a look at. It's idtechex.com/PE. And here's a summary of all the other reports we also have on the topic, which ranges from reports looking specifically at different materials, such as conductive inks, to barrier layers, to quantum dots, to reports which look at different types of components, such as printed batteries, sensors, displays, through to end-use applications, such as reports we have looking at e-textiles and smart packaging. So thank you very much for your time. If you have any questions, then feel free to email those through to us. And we hope you'll join us for future webinars and take a look at our website, IDTechEx.com, for more information going forward. And just a reminder, our next event on this topic will be in Berlin in April on the 10th and 11th in 2020.